If you're following the IoT show, you know that IoT development is not an easy task. But there are tools out there, solutions, that will help you go faster and that will abstract the complexity of embedded development, connectivity to the cloud, and more. One of these solutions is called Particle. Zach Supalla, CEO and founder of Particle, is joining me on the IoT show to tell us about the inception of the company, its mission, where they're at today, where they will go tomorrow. One of the topics we'll dig into is why and how they bundled connectivity for multiple radios into a single system on module. Imagine having cellular, Wi-Fi, satellite, and eventually LoRaWAN in a single module that you will put on your IoT device. Well, don't miss that new episode of the IoT show. And if you like the show, don't forget to subscribe, to like, to tell your friends about it. Hi everyone, this is the IoT show. Thanks for tuning in. Today we have Zach from Particle to discuss IoT in general and Particle. Hey Zach, how are you?
I'm doing great. How about yourself?
I'm fantastic. I'm great here. I'm enjoying the first day of sun. Actually, not so much sun. We're mid-June and weather is not yet settled in the Seattle area. Where are you at?
Right now I'm in Philadelphia and it is 89 degrees outside. So I'm very much relying on the air conditioning.
Is it? Yeah, we have that heat wave coming up like for all the Midwest down there, Southeast and so on. And now we are in like freezing temperature and I'm hearing it's going to snow in the Rockies, something like that. Stupid.
Yeah, nuts.
That's scary. Well, so Zach, before we get into the conversation about IoT and all of that, we're going to geek out for some time this morning. Mm-hmm. Tell us about yourself. Who are you? People might not know you. So who's Zach?
Mm-hmm. So my name is Zach Supalla. I am the founder and CEO of Particle. And at this point, I mean, it's hard to define myself other than as Particle. I started the company when I was 27. I'm now 39. So I've been doing this for 12 years. And so most of my professional background is building this company. But if I rewind the clock to when the company was founded in 2012, this was sort of early days of IoT. This was when Nest had just come out. And so I think the current phase of the industry, meaning IoT as opposed to like M2M or the sort of prior generations of the same set of technologies, was really at its at the very beginning. I was coming out of grad school. I was doing a joint business and design degree, so I have an MBA and an engineering management design and innovation degree. And while I was in that program, I started thinking about wanting to start a business and build a product, and eventually that would become Particle. Started as Spark and actually started as a connected lighting business. My dad is deaf. I wanted to make his lights flash. And when my mom sent a text message. And so that sort of was the genesis of the thing that eventually became, went from being a connected lighting product to a development board to now an IoT platform business.
Yeah. So if I remember correctly, one of these first development boards was round and it had LEDs around it, right?
Yeah. Wait, do I have one? Yes. The internet button.
Yes, I remember that one.
It still exists.
I played with that one like a long time ago.
The, some things that are just like, we even put in a little round aluminum, like tin can kind of a thing. But yeah, there's some, there you go. That's the Photon development board in like a little LED button thing. So
yeah, and that as you were saying, 2012, like really like the inception of everything. And I remember playing with this very hardware, and at the time was really interesting already because you were trying to democratize the development for this kind of devices, so that more people could touch it and work with it. And as you were saying, like technology for M2M and automation and things like that were already like in full swing in terms of development and evolution. But I think people like you started making IoT and embedded development more accessible to more developers. Starting really, I would say that the birth of what IoT is today, which is it's still for enterprise. People see it in consumer a little bit, but it's everywhere. It's really a technology that is behind a lot of what's going on in the industry. Can you tell me, what is your perspective on where IoT is at in terms of, is it like exploding, growing like steadily, falling apart. Where do you think IoT stands these days? And oh, actually, I forgot to ask you, what is your definition of IoT? Because here we can talk about a lot of different things depending on who we're talking to. Definition of IoT and then where it stands.
Yeah. So, I mean, I think I share an opinion, I think, of a lot of folks in this industry, which is this is such a terrible name. But we have to use it. We have to use it. It is it is the adopted name of this industry. But in general, the way that I define Internet of Things is essentially that there are a bunch of technologies that we made in prior generations, or sort of like technology generations, primarily for the purpose of PCs and smartphones, right? And so, like, I mean, starting with computers, right? We processors obviously preceded the personal computer also, but like mostly grew into massive adoption through the PC generation. The
Mm-hmm.
internet was built for PCs. Then we started getting into wireless technologies. So we built Wi-Fi for PCs originally. Then we built the cellular networks. Cellular networks also, predated smartphones, but ended up getting widespread adoption through smartphones. And so, if we look at these sort of primary technologies of compute, connectivity, the internet, wireless radios, all were created for specific purposes of PCs and smartphones and the internet. And then they got to be cheap enough and ubiquitous enough that some smart people started to realize that you could take these technologies and you could use them for things that aren't PCs and aren't smartphones. And so my definition of Internet of Things is it's kind of the miscellaneous bucket of the internet. It's really just the non-smartphone, non-PC applications of those technologies, which is a terrible way to define an industry because it's the other bucket,
Yeah.
right? And the other bucket is very large. And
Yeah.
so then I generally will break that down into, like, you have consumer IoT, which is what we normal human beings are mostly aware of because we are consumers. So we have, home automation stuff or whatever. Um, I think there's a whole subcategory of that that's like media, right? So like set-top boxes and things like
Mm-hmm.
that. Um, the Then you have automotive, which is another category that we normal human beings are exposed to because we have cars, and so the connected car has become a big part of that industry. And then now we have another miscellaneous bucket, industrial, which is also kind of everything that isn't consumer and isn't automotive. There is a phrase, industrial IoT, which often ends up specifically meaning factory automation or building management
Yeah.
systems as like the sort of two subsets. But more broadly, what we see is, and where Particle mostly plays, is selling our technology to companies who are making some kind of industrial equipment or machine, which can be agriculture, can be healthcare, it can be commercial HVAC, energy, oil and gas, right? There's a lot of stuff that, again, I'm industrial in this context, I'm using as non-consumer,
Yeah.
non-automotive.
That makes sense.
And so that's where we play. But like IoT is this big, messy, miscellaneous bucket of the internet.
Yeah, and as a matter of fact, and you just described that, it's pervasive. It's everywhere, right? It's technology that is visible for some of us consumers, right? Is not that visible, and actually, it's a good thing to me. That IoT is not visible is a good sign because there's no problem. That means it works, and that's what you expect. I like to when people are asking me and they're not in tech to define IoT. I'm using an analogy. I'm saying, in a house you need an infrastructure such as wiring for electricity, for networking, and for water, and basically that allows you to have comfort, to have features in the house that are necessary. Well, IoT is for industry, whatever kind of industry, the plumbing and the electricity, right? It's the part that connects the thing to one another, to an infrastructure, allows exchanging data, extracting data, sending commands, remotely monitoring, remotely controlling, etc. And people get it. People get it. And what they get immediately as well is the fact that it's here everywhere. It's in the cars, it's in your house, it's in the POS system you're interacting with at the cashier. It's pretty much everywhere. And so that people relate to that. And I think from my perspective, it's growing. What I'm interested in is, particles and Spark before that is not new. And as you were saying, you started there pretty much.
Mm-hmm.
And you're still in there. So that means it's working. But, you had to adapt to the evolution of the market, to the demand, to the ask from the customers. Otherwise, you wouldn't be here anymore. Can you give me like this the summary of what were the big milestones for in the realization in the evolution of particles since its inception to until today? And we'll talk about the latest announcements and where you're at.
Yeah.
And but I'm curious to know from your perspective, what are the milestones? What are the big things that have marked the particle history?
Well, if I go back to the original genesis of the business, right? So we started as a connected lighting product, and the the premise of that product. I mean, I talked about my my dad, and I wanted to make his lights flash. But if we really step back, the there were starting to be connected lighting products, and there had been prior to this. Like X10 is a home automation technology that's been around since like the 80s. Um, we were not the first company to think of connecting lights. But what I recognized is that for that particular application, which is okay, I want my mom to, if my mom texts my dad, I want the lights to flash. That shouldn't be a product. That should be an app, right? Like it should be the case that things like lights have an API, and that software developers can write applications that interact with those products. And I
Mm-hmm.
wanted to build an app, not a product. But products didn't exist at that time that you could write apps against, and that has changed, right? I use Home Assistant in my house, and like it is amazing how much stuff is now API driven and can be
Yeah.
controlled through these kinds of systems, right? But that was not true at the time. And so when we launched the Spark Socket, which was the first product that we attempted to launch on Kickstarter, which is almost impossible to find because it didn't hit its goal, and things Kickstarter campaigns that don't hit their goal get taken off the internet. The That premise was about like apps for lights. Now that product didn't go anywhere. Um, but in building it, I think we discovered a couple of important things. One is I continue to believe in that premise that like products have applications, and that there is in many cases the manufacturer of the widget is also the company that's building the application around it. But there's this sort of infrastructure that sits in between, which is how do you get the thing onto the internet and create like a secure a secure and reliable messaging pipeline such that machines can have APIs, right? That's
Mm-hmm.
the sort of core premise of what we've built. um, and what we recognized in building that product ourselves is that it's hard. There's a lot of technology that needs to get built. It's very broad, it's very deep. Building an IoT product is very challenging.
Mm-hmm.
And if we look at the web, the way this developed from mid 90s to like even today, right? The It got cheaper and easier to build websites, right? If you wanted to build a website in 1994, you were going to have to hire some very specialist people and spend a lot of money to do it. And these days, I mean, anybody can build a website, right? You've got a million great products that I could build a website while we're talking, right?
Mm-hmm.
The And so I think that that abstraction has happened over decades as the abstraction of web technologies has outpaced the introduction of complexity into web technologies. The web also can do a lot more now than it could do before. Our
Yeah.
computers are more powerful. Our browsers are more powerful. JavaScript is more powerful, right? The But abstraction has outpaced complexity. If you look at the Internet of Things, it is harder today to build an IoT product than it was in when we launched the Spark Core, which is our first development board, in 2014. So
Mm-hmm.
10 years have passed, and IoT Analytics just posted a report that says the average time to market for an IoT product is 41 months. So that's 3.5 years. And that's
That's a
up from
lot.
26 months the last time they did the report, which is maybe 2 years ago. And so that's weird, right?
Yeah.
Because there are people like us that are abstracting things, right? So why is it getting longer? And what I see is that the technologies that are available are progressing very quickly. And so what one can do today is very different than what one could have done 10 years ago. And but those technologies are very complex. And in general, the complexity is outpacing the abstraction, right? So it is getting harder, not easier, and more expensive, at not cheaper, to build an IoT
Mm-hmm.
product.
Yeah.
Um, and so that's, I think, the sort of context in which Spark and now Particle enters the world. Is we built the we tried to build our own product. It didn't go anywhere, but we learned from that what the technology and infrastructure needs were. And we said we want to build this so that other people can use it. We saw an opportunity to do what Stripe did for credit card processing, what Twilio did for sending text messages and applications, we wanted to do for IoT. Like, let's abstract away the complexity and make it
Yep.
possible for developers to build these kinds of products. We knew that we were building a B2B business, that the thing that we were going to sell was a thing for companies to build products.
Mhm.
Um, and the way that we chose to get started on that was to make it easy for developers. And so our first product, the Spark Core, launched in 2014, was a development kit that we launched on Kickstarter for prototyping, in the same vein as an Arduino or Raspberry Pi, but the big difference being that it was connected to a software platform that was designed to provide a secure and reliable infrastructure for communicating with those products. And over the last 10 years, we continue to make development boards for prototyping. We continue to make a cloud platform for communicating with those devices. These days, we make 90% of our revenue selling that cloud platform.
Okay.
But almost all of our enterprise customers start as an R&D engineer with a development board. And so the sort of core premise of the business is every product starts as a prototype. And if we
Mhm.
make it easy for that engineer, that developer, to build that prototype, they will try out the platform, hopefully have a good experience, discover what we do that makes them reliable and secure, things that aren't actually necessarily part of the prototyping experience. We really focus on the kinds of things that are going to matter when you actually launch this product.
Mhm.
And that hopefully means that that company will continue to use the Particle platform as that product gets out to market, and they start
Yeah.
powering it at scale.
Yeah, I like your analogy with web because web technology has evolved, as you were mentioning, from DIY, like you do everything yourself from scratch. You even like we were even hosting our own servers, right? You were a developer, you had your own local IIS server to test your development. And then you were hosting one in your companies. There's not even like clouds, so you had to scale your cloud, your own servers or whatever to have
Mhm.
your website out there. And we've moved like to a point where everything is abstracted. You know, your servers, your hardware is abstracted, your browsers are abstracted through APIs. You have like lots of libraries you can use with different languages, and you basically had these software building blocks that came, but hardware as well. We forget that the web has evolved because hardware has evolved as well,
Right.
being abstracted, right? And I think IoT is the same. You were describing that. Um, I believe personally that today you cannot start an IoT project from scratch and do it all, like design of the hardware and the real-time OS, and because there are existing bits and pieces out there that you can aggregate and you will compose from. And then the level of abstraction you need will depend, right? But I think I've been playing around with the particle, the latest like the Photon 2 and a couple other ones. And one of the things that's really struck me is that the level of abstraction is, to me, well tuned because you have access to the hardware features
Mm-hmm.
without having to think too much about it. You have access to connectivity. This one is like totally seamless. Like I'm still curious to look at the APIs for manually switching from one network to another one because I just like call particle.publish and it sends data. I'm just like, is it cellular? Is it Wi-Fi? Is it like, do I care? Actually, maybe not. And then the cloud platform is also a level of abstraction, right? It at the end of the day, does it matter that you host the server parts on your own premises that will receive data from the devices to then send it to your business apps? Or could it be outsourced? Could it be somewhere else?
Right.
It's for every customer to respond, right, and to pick the right option for them. But I think the level of abstraction is really well tuned, and will definitely fit in my view a lot of customers out there. So I really appreciate that. I really like the way you're presenting that as well. It makes a lot of sense, and it goes along with that story of IoT is about putting bricks together to
Right.
create an application, and don't start from scratch. Don't start building your own bricks with mortar. Like just buy the bricks and
Right.
assemble them. Right. That's pretty much where we're at.
Well, I think I appreciate that, and I think that that is the biggest challenge when designing a system that is an abstraction to a technically complex problem. Is you have to choose your abstractions, right? You have to choose
Yeah.
which problems you're going to hide from the user and which problems you're going to. I put another way, which problems you're going to solve for the user, which problems
Mm-hmm.
you're going to leave for the user to solve,
Yeah.
which information about the infrastructure you're going to show to the user, which information you're going to hide from the user. And the if you do it right, the experience of the person building the thing with the infrastructure is, wow, that was easy and it just works, right? And if you do
Yeah.
it wrong, their experience is, I can't get this thing to do what I need it to do, right? That's the thing that we are always trying to avoid, is the
Yeah.
circumstance where the abstraction is a barrier to your development instead of a support to your development.
Yeah.
And so finding the ways where you say, okay, how do we expose these APIs? What is available to you? What is the smart default, right? So you're talking about like wireless networks. Which network is this data going over? Wi-Fi, cellular, satellite, LoRaWAN? Do I care? You do care sometimes,
Yeah.
but
You
not
do.
always, right?
Yeah.
Because it may be that like you might say, look, as long as the message shows up on the other side, I care. But those have different power envelopes, right? So like if you rely on one over the other, it may consume your battery at different rates, and that might matter to you. It will matter to one user who has a battery powered product, and it won't matter to another one whose product is plugged into the wall. So then there's a cost difference, right? Which is like the satellite network costs more than the cellular network.
Mhm.
Does that matter to you, right? And I think this is where the answer is not the same for all parties. And what we want to do is try to provide something that works really well out of the box, that you don't actually have to think that hard about these problems early in the development process when you're just trying to figure out how to make a thing that works. But
Yeah.
then later, when you say, "Oh, I need to have a little bit more control. I need to tweak things," you can do that, right? You can make the changes that are necessary to work the way your product has to work.
Yeah. That makes sense. The one more thing that you'll need is for customers to start trusting you, right? When you give someone not a black box, but something that works, and sometimes there's some black magic in it, right? It just works, right? Like I was mentioning, which network is he using? I'm just using one API for publishing data, and it just publishes it. There is a need for customers to be acquainted, to test, and then to really start trusting the technology. So it has to go to production, at some point. One thing that I've noticed the industry is really struggling at is going from a prototype priority project to
Hmm.
production.
Right.
And I do believe that abstracting complexity, not at a super high level and saying, hey, here is a big solution that does it all. And, you just have to do SaaS, whatever interface for creating your dashboard, but all the rest would take care. I'm not a strong believer in that because there's too much things that can go wrong and that is not customizable or adaptable. And then when you go from a proof of concept where everything works magically at once without you even like doing anything, and then you want to go to production, usually it doesn't work. It doesn't
Right.
work because cogs, because like a bunch of things. I
Yeah.
think from what I've seen, you went into the SOMs, system on module format, which allows to have an evaluation board and eventually a prototype that is using the exact same hardware
Mhm.
that will go to production, which
Right.
makes that transition from prototype to production like seamless, right? So, from your perspective, that also one of the things you try to unblock customers on.
Yeah, I think the way that we look at that transition from prototype to production, and again, maybe starting with a reference to the web, right? Uh, these days, the technologies that you use in general for prototyping and production in a web environment are pretty similar, right? So, like, well, let's just talk about programming languages. JavaScript. JavaScript is great for prototyping. It's also great for production. It has the characteristics of something that is great for prototyping, which is basically ease of use, right? And like developer productivity. Which is kind of a different way of saying ease of use, but like, can I sit down and work and get a lot done in a short period of time? That's what you care about when you're prototyping. And then when you're in production, you care about security, scalability, reliability, cost, right? These are the things that matter to you. And web technologies typically these days strive to get both, right? Which is not necessarily for all use cases. Someone might choose to use Python here and JavaScript here. Not every technology is great for every application, but most of the technologies we use cut across that chasm in between prototyping technologies and production technologies. I think that it's interesting how the IoT world has um, has gotten kind of stuck behind that, and I think that is a result of the sort of early silicon world, right? If we sort of rewind back into the 90s, working with silicon, like embedded systems, microcontrollers, you really had to know what you were doing, right? You had, if you weren't a professional embedded systems engineer, you should not be touching that stuff. And then
Yeah.
Arduino came out, and I think they deserve a lot of credit for creating, the sort of the premise of what originally started with a wiring project, of which Arduino is kind of an offshoot, as a way to take those embedded technologies and make them easy enough for like designers and artists to use, right? Which was the initial sort of what that product was originally designed for. Then that turns out to be great for STEM education, and so now like kids are growing up learning Arduino, that's new, right? And then
Yeah.
Raspberry Pi, I think, followed a very similar path in really starting out focused on ease of use. Now, what ended up happening is that now you have this world where you have sort of Arduino as a easy to use thing, uh, and then you have all these other embedded technology stuff that is still very difficult to use, but is what the professionals use. And the gap never got closed. And so that was when we started, that was something we were very aware of, is like, I think it's odd that like nobody has actually sort of tried to figure out how to cross this chasm. And I think part of it is hard. It's hard to build something that is both very easy to use and secure and reliable and scalable and affordable.
Yeah.
And so that has been something that we've very much focused on, is trying to kind of cross that chasm, and that comes out in the form of the software, but also like hardware choices. Like, yes, we have development boards and SOMs, and we try to create this very smooth path from the development board to the SOM. Now, I'll also tell you, like, a bunch of customers ship products with the development board in them. And so that was something that we used to have a lot of anxiety around, is like, oh man, we literally made the SOM for the production product, and we get a little uncomfortable about the fact that a lot of people ship with development boards, at least we used to. And now we've just decided sometimes that's what people want. They just want it. They want to ship quickly, and they don't want to have to worry about it. And so what that has led us to do is make sure that all of our development boards are very well designed and robust. And like, what we don't want to do is have that customer who ships with the development board regret it afterwards. And so now, like,
Yeah.
if you ship a product with the development board, that will work pretty well. Like, that is
Yeah.
a good, high quality, industrial grade, reliable product.
So yeah, just knock yourself out. Go with it. Yeah.
Right.
Well, and
We do
the
not
other
get to
thing is
control what the users and customers do, right? So we have
true,
to
true,
learn from them and
true. True. Even though development board, have all the connectors, bunch of things that are potentially liability in a production device, unless you do a really nice case, or unless the device is really not accessible, not in any situation that could be impacted by this liability or this risk of like having two pins connect each other because there is a drop of water or something like that, right? Which can mess things up once. If you design, your own board that is specialized what the device is supposed to do, these are things you would definitely avoid and get away with. But once again, not everyone needs that. Not everyone wants to go there, and it's so fast to go from the prototyping and evaluation. Evaluation, prototyping, and then production using the same hardware and software that it's pretty amazing. So we spent a lot of time setting up the stage here, but what I want for you now is to tell us what's the latest news about Particle. Hopefully, people will be interested again if they were not, or interested in knowing what's the latest. And so, tell us, what is it that you guys have recently announced that people should pay attention to?
Yeah. So earlier this year, our big announcement earlier in the year was multi-radio. And I think actually setting the stage for multi-radio there's a little bit of context setting there. And so, rewinding a bit in our history, the first products that we launched 10 years ago were for Wi-Fi connected products. And then shortly thereafter, we launched a platform for cellular connected products. And so it has been the case for 7 or 8 years that Particle has had support for Wi-Fi connected products and cellular connected products. And in having that support, I think there's a couple of lessons we've learned. It's typically the case that Wi-Fi connected products, they're usually consumer products. The cellular is used more often for non-consumer applications, and Wi-Fi is used more often for is used more for consumer applications. And in some ways that are sometimes surprising. Like, I think we thought that, for instance, commercial products used in an office environment would use Wi-Fi because, I mean, offices have Wi-Fi, of course. This
Yeah.
is how we connect our laptops at work. But the challenge with a Wi-Fi network in an office is it has an IT administrator who may not want these IoT things on their network, right?
Yeah.
Because they don't like figuring out if that product has security risks, and many IoT products do have security risks, is challenging for them.
Mhm.
Now, to some extent, you might say, well, but Particle has this great security story, and we can help provide the evidence and which we can and do. But still, for most of our customers, it's easier just to say, just use the cellular network. And
Yeah.
that way, you don't have to worry about the IT guy who's going to block that product on the network. And so um, that has been this common pattern of like cellular for non-consumer, Wi-Fi for consumer. But we also saw this interesting crossover where we had consumer products that are outside of the house, like in the backyard, that were cellular connected, or products that were using the cellular network, but would sometimes find themselves in situations where there wasn't a good cellular tower, like oil and gas, methane emissions monitoring in the Permian Basin in Texas, which is this big area of Texas where a lot of oil extraction is done, and methane emissions monitoring is one of the more common use cases of our platform. So you can, which is great, right? We're trying to reduce the amount of methane that is escaping into the world as a result of oil extraction. We also have customers who do that in waste management and in agriculture. The Permian Basin in Texas is notorious for terrible cellular networks. And so, because there aren't people there, right? This is one of the things that we've learned is many IoT products go in places where people are, and these networks were made for people, smartphones and PCs. But a lot of machines go in places that people don't go. And in those cases, it is often very challenging to get access to a wireless network.
Yeah. Yeah.
So we have cellular customers who will backfault to Wi-Fi and try to establish Wi-Fi networks when they don't have a cellular network. We have cellular customers who backfault to Wi-Fi, or sorry, we have Wi-Fi customers who backfault to cellular when the Wi-Fi network isn't reliable. And so we started working on an integrated system with Wi-Fi and cellular. It's like, well, why don't we just make this one product?
Mhm.
And as we brought that to market, we realized, the value proposition here is not Wi-Fi plus cellular. It's what people are looking for is, I just want to plug this thing in and have it work. And I actually don't want to know that much. I don't want to have to know that much about the wireless network. I just want to plug it in and have it work.
Yeah.
And Wi-Fi and cellular get you most of the way there. But to truly get there, you need to add 2 more radios. You need to add satellite, and you need to add LoRaWAN. And so when earlier this year, we launched our multi-radio product, and the tagline for it is Connect Anywhere, which is Wi-Fi, cellular, satellite, and LoRaWAN in one package. And the story we can then tell to a customer is, look, there is not an environment out there where you're not going to be able to figure out one of these technologies. And what we're doing is we're replacing the complexity of figuring out which radio to use in which product with a different complexity, which is 4 different radios that work in wildly different ways. Like the protocols behind these radios are not even close.
Isn't that 5 with BLE?
Yeah. Okay. So throw BLE on there, and
It's just
I would be
random.
remiss to not add that it also
One.
supports Ethernet connections, and so it's actually 6. And if you count the wire, and so it's really like you will be able to figure out some way to connect this thing. But that means that there is now a networking protocol layer of complexity that we've introduced, which we then need to solve by having an abstracted way to communicate, such that you can say, if I particle.publish a message, it will show up on the other side, regardless of what radio it's going through. And so that's the product we announced at the beginning of the year. We're shipping a couple of versions of that. We have others coming later this year. And so yeah, that's been a big push for us.
Yeah, and you can get some evaluation board for like less than $50 that have all these connectivity. I tried the Boron one was cellular connectivity. I was activated in like 2 minutes. And I have my device connected. Another super interesting thing while you're in development that I really liked was the ability to deploy your code from the browser, while code in the browser and deploy from the browser to the device, which might seem, obvious for people who are in the domain of mobile development or things like that. For the people who are embedded, it's like, oh, wait a second, what did you just say here? It's just still not trivial to do that
Mhm.
today. As we're saying, embedded development is still hard, and I don't think it's going to get any easier. What's going to get easier is building apps. I like the way you're presenting that, building apps that are running on embedded devices by not having to reinvent the wheel and rebuild all the lower stacks.
Right.
The term, and by the way, the terms, BSPs and HAL and all of these terms, when I talk to younger developers, they're coming
Mhm.
out of school, they have no clue what I'm talking about. Sometimes, like I talk about real-time operating system and threading and memory and virtual memory, and they're just like, I have no clue what you're talking about. I know JavaScript. It's like,
Well, that's because right, the web technologies and really PCs and smartphones, we're so used to we're working 15 layers above the metal, right? And
Mhm.
there's so much that the operating system is doing, whether it's Linux or Windows or Android or iOS or Mac OS or name your OS, right? That OS is doing so much work, and we just get used to the OS being there. And then you look at embedded systems where you're much closer to the metal, and that stuff doesn't exist. And so, in some sense, Particle's device OS, which is our embedded operating system that runs on these systems, like is building back in a lot of that abstraction, but
Yep.
in a way that makes sense for embedded systems that are much more resource constrained, that are real time, uh, to get back to the place that your smartphone is, which is like it just works. And in some sense, I think going beyond it, because like your smartphone works, but you might occasionally turn on and off your cellular network because how many times have you been on a Wi-Fi network where it just stops working and then you turn off Wi-Fi so you can connect to the cellular network? Like you are manually intervening to try to get that thing to work. Particle powered machinery deployed out in the world doesn't have a person who can press the button to turn on and off one of the radios. And so device OS is doing that. It's trying to
Yep.
find the best network, and if it has networking issues, it will reattempt to find the best network to make sure that that device can continue to perform reliably.
Yep. It has to work.
Yeah,
That's the bottom
yeah,
line, right?
right.
Cool. Zach, before I let it go, can you tease us a little bit about what's coming next? We're so multi-radio coming up, like great cloud platform. You have different types of hardware available with different networking. You have the asset tracking solution, gateways, bunch of things. People will go on the websites, but there are a couple of things you want to give us a little taste of what's coming next. That'd be great.
So I think that the sort of taking a look at that story around multi-radio is um, connectivity is a big part of what we do, and multi-radio in some sense is like the epitome of like the connectivity thing, right? Which is a bunch of radios that just work, and we're now trying to truly solve connectivity. I think that the next piece that we're thinking about is in some sense the same thing for compute, right? And what I mean by that is every processor that we've provided over the course of Particle's history has been more powerful than the prior generation. And to some extent, that's Moore's law, right? Like microcontrollers in 2024 are much more powerful and have a lot more memory than microcontrollers in 2014 or 2013 when we launched the Spark Core.
Mhm.
Uh, and so we've been creating systems that have more and more application space, more and more capabilities, where now you can do things like handle media and you can handle ML models and things that are much more computationally intensive. And when we look at that space, we're not done. There's more for us to do, more powerful systems for us to bring into the platform. And so we have some announcements coming this summer about really stepping into much more powerful processors and systems that can handle a
Okay.
lot heavier media and heavier models and really support the workflow of deploying software applications like you did with the over-the-air software update, right? Which is a big part of what we do. Really adding strong support for ML and deploying models to devices and iterating on those in the same way that our customers
Yeah.
iterate on the software applications that they push out to
Yeah.
the device. So
That's
that's coming around
exciting.
the corner.
That's exciting. So I know like all the Gen AI buzz, like everyone is going crazy about, make some of that more rational, useful machine learning not so visible these days, but I'm convinced that it will come back pretty hard because people are starting to think, hey, if I can do AI on my phone, why can't I do AI on my robot arm controller? Or, and then they start looking at, but what does that mean, AI on that thing? It's not just about talking to you or understanding what you're saying. It's about doing anomaly detection. It's about detecting trends in signals. It's about reacting rapidly to a situation based on a lot of parameters. And that's going to be super interesting. TinyML, which is about putting machine learning in tiny devices,
Right.
definitely is to me, it's going to be big. So great, Zach.
And I think
Wait, go ahead.
I was going to say, I think that in coming back to how we started this conversation, right? The Internet of Things is just a repackaging of the technologies that made the internet work for things that aren't smartphones and PCs. And one of our investors has a phrase that he uses of the peace dividends, which is, this is an old framing from like World War II, where we made a lot of technology progress after World War II, which was that the technologies that we invested in R&D to go to war, after the war was over, we get the peace dividends of those technologies, which is like we can reuse those in consumer applications. That's what created the middle class
Mm-hmm.
and the sort of all these things that we have today. The internet or the IoT is the peace dividends of the PC wars, the internet wars, and the smartphone wars, and the Gen AI war is currently ongoing, right? And so there are many companies who are fighting that war, and the peace dividends are low cost silicon and AI accelerators, great tools for being able to train models, great models, right? These are all the peace dividends. And so then the question is, how do you take the peace dividends of the AI wars and apply them to IoT devices so that people who are doing machinery and sensors and equipment and can use that stuff to create
Yeah.
value. And so that I think is a huge opportunity. TinyML, Edge AI, whichever version of it, right, is I think going
I've,
to grow because it's there and
yeah,
available for us to use.
I've heard the term AIoT recently. Uh,
Yeah, I've heard that too. I don't like that one, but it's going to be popular, and so it's so it is. This is the
it's a term. It's a buzzword. Anyways, we'll surf on that. Anyhow, Zach, that was fascinating. Lots of information to unpack. There's going to be more announcements from Particle. You told me that, but we can talk about everything today.
yeah,
And I really appreciate your time today. I invite people to go check it out, particle.io, play with it, get a kit and go play with it.
yeah,
Get the boron run and get cellular connectivity and put that into your garden moisture measurement system in your backyard,
right,
or things like that, right?
that's right,
Zach, thanks a lot for your time today. Again, see you soon.
absolutely.
Bye, everyone.